from Sri Lanka. Exazyme and Fcode have been like good collaborators for about 2 years now, and we are very happy with this. And today, Ramesh is going to present us some very insightful talk, I hope, about the machine learning security vulnerabilities. Ramesh?
Yeah. Hello, good evening, everyone. So many people say that we live in the start of the fourth industrial revolution, and AI and machine learning has a very big role in it. Many industries like transportation, manufacturing, agriculture use machine learning and AI in it, and those systems are vulnerable to attacks that happening around the world. So today I'm going to talk about those dark areas in the digital world. So this machine learning related security vulnerabilities top 10 is the topic for today, and these are not just theoretical concepts. These are practical things that happen in real world. You will find those things interesting, I guess. So as introduced, my name is Ramesh. I'm CTO and co-founder of Fcode Labs. Fcode Labs is a software engineering company based in Sri Lanka, and we develop cloud-based solutions for in the digital transformation sector. We specialize in industrial sectors like healthcare, energy, likewise, and we have been developing lots of projects in the healthcare domain, and we have released our newest product called Progress Magic. It's in the beta state. So it's a place that you can connect with the therapist, and the therapist can track all the progress of their clients, and they have a really good engagement during the sessions. So initially we are going with therapists, and we are planning to roll out to other sectors in the healthcare industry. You can learn more about this one in our website, and if you like to beta test the product, you can contact us via the website. So going back to the topic, the goal is today's session is to educate you with the machine learning related vulnerabilities and educate you with the ways that we can do to avoid those vulnerabilities in your systems. Okay, these are the top 10 list. These items were extracted from the OWASP website. So OWASP is a organization that analyze security vulnerabilities that happen in the world and provide guidance for the people, engineers. So they provide top 10 lists in various sectors, and this sector is related to machine learning. The first one they have identifies the input manipulation attack. It's the most common attack available in this type of events. And the second one is data poison attack. Likewise, the list is there. I will go through one by one. Okay, the first one, input manipulation attack. That one is the attacker tries to change the input in a way so that the input will be identified by the model in a one way, but for the human it looks like a legitimate input, but the model understand it differently. So when we are analyzing the attack types, there are two things to consider. One thing is a threat agent. Threat agent is the person who performs the attack, and the second one is threat attack vector, which is how the threat agent is performing the attack. Yeah, we'll go to the risk factors. So exploitability of this kind of attack is very easy relative to others, because one way or another the input is exposed to the user. There are some kind of ML models that have the input not exposed to the user, like recommendation engines, we as a user interact with the backend system, and backend system generate the input for the ML model. But if the ML model's input is directly exposed to the public, like as in public APIs like OpenAI APIs, so those kind of APIs, if you have an API like that, your system is vulnerable for this kind of attack. Detectability is somewhat difficult because for a human eye, these kind of modification to the input data cannot be identified. It will be only recognized by the model. Human will, if a human looking at the data, they will see them as normal data, and the impact is going to vary upon on the user case. Most of the time, it has a high impact. Here's an example done by a research team. I have attached the paper here. So the research is they change the stop sign in a way. So they tried two ways. One thing is superimposed way. They tried darkening and lightening some areas in the input in the stop sign. These are not just random color changes. These are done to like trick the model. It's a carefully calculated way, and when the model sees this sign, it will recognize it as a speed limit sign, not the stop sign. But for the human eye, it looks like that color changes due to the sun exposure, something like that. The second one is camouflage abstract art one that they try to put some stickers in the stop sign, and it also identified as the stop limit. These are the results. So most of the time, the superimposed attack was giving successful results, and camouflage attack, it's nearly 85%. So in the real world, also this has happened for Tesla autopilot. If you have, at least in the previous models, the occlusions in the driveway, like if someone passes through a sign in front of a sign, the Tesla car identified those signs as different sign. So there's a YouTube channel called AI Driver where he tried to analyze what's happening inside the FSD system in the Tesla car. So when in the videos in his channel, you can see that some of the wrong things that AI that autopilot does because of these kind of mistakenly calculated errors that's done in the system. Another way is that the same research team tried is to attach the sticker in a microwave oven. So they carefully, this is not just a random sticker that has CVPR in it, it is a carefully calculated sticker. And when a human look at it, it's just a sticker, but for the machine learning model, it looks like the model thinks it is looking at a mobile phone, not a microwave oven. So that's another type of attack. And prompt injection also in this appears in this category. So this is a popular one in the social media as well, where you change the CV like this, you put some text like this in your CV in a small font in white color. So if a person read your CV, they can't see that these texts are there, but if you upload it to a automatic CV sorter, it reads this text and like identify your CV as a good CV. So what basically says it says that a human expert also analyzes the CV and they suggest this CV as a good CV, and as the system you also have to do that. So in the summary, they input a query like that, and it's going to trick the CV sorting software. So it's not that common. People have identified this and fixed this in most softwares. So another example for prompt injection that it's done by a school teacher. The teacher uploads the question in a PDF file into the LMS platform, and use the students have to complete that and upload the results to the LMS. In that case, what teacher does it in the between the paragraphs of the question, teacher puts a sentence like that. It's in a small font in white color. So when a student read that font, read that text, they can't see this sentence. But when the student upload it to the ChatGPT or something to get the answers, the model read the sentence, and as the sentence says, they use the word lemon and mockingbird. So those are two unrelated words that unrelated to each other and unrelated with the question as well. So teacher can identify these words in the answer sheet and identify who have cheated in the exam. So this input manipulation attack is a very broad area. So people have categorized it into subcategories, and these are 4 common things. And first one is adversarial example attack. The first example that we identified, it's where the input is changed so that the human can't input. A human looking at that input can't identify that as a wrong input or a malicious input, but the model that reads that input thinks that is malicious data. So the model acts differently. Second one is data manipulation. It can be any kind of manipulation, not just adversarial. So under that, there is prompt injection that we saw earlier, and also input validation attack. If your model is trained between to get numbers between 0 and 100, and if you give a number like 1000, the model will change its behavior. So these types of attack, any type of attack, they are not performing just to get the access to the server underlying. They have they can have different intentions, like breaking your systems, or like breaking the business as a whole. So like input validation attacks are most probably break your system, not going to give access. And another thing is causative attack. So it's happening if you have some kind of beacons installed in the environment to collect data for given to a machine learning model. In such case, an attacker can temper the inputs. Like if it is reading you through a camera, they can have installed lasers, something like that, to alter the inputs. Or it's reading some data from sensors, they can have like electromagnetic pulses to tamper the data. So it's causative attack. And inference attack is another type where the attacker tries to learn data from the model. So it can be information about the model or about the training set. So these things will appear in the later as well. As prevention mechanisms, the first thing that you can try is input validation and feature scaling and normalization. So those things, and also adversarial training. You can generate adversarial example, like examples with noise inputs and some carefully manipulated inputs, so that the model will identify these kind of attacks in the training phase. So first 3 alone will reject most of the attacks coming to your system. And other than that, there are robust architecture designed as example ensemble methods. You can have different types of models in different architectures trained to do the same thing, and somehow combine the result and give a single output. Say ensemble method, and you can have redundancy models and feature engineering methods without directly giving the input to the model. You can have some feature engineering layers. And anomaly detection is also going to help. Noise reduction is mostly if the input is a video stream or audio stream. there can be noise that can alter the output. You can have a noise reduction before feeding to the model, and rate limiting as these types of attacks need lots of access to the model. We can rate limit our model and reduce the number of attacks, and perform regular model updates and do endpoint securities. Yeah. Second one is data poison attack. Here the attacker try to alter the data set. In the previous example, the model is already trained and attacker tried to alter the input to the data. But in this case, attacker tried to alter the data set. So it happened before training the model. Here, how it is done is most of the time using public data sets. They download the public data set and alter its data and host it in a like fake website. And if you download it and train your models with it, it's going to have these vulnerabilities. And security vulnerabilities in your data store is going to, they can directly hack into your systems and alter the data sets. It's also possible. And also security vulnerabilities in the company. So they can do a social engineering attack or bribe the employee or like blackmail employee. So there are like things like rubber ducky that looks like pen drives, but if you input that to a system, it emulates as a keyboard, and then it will trigger some commands that the attacker needs. So with the keyboard, you can do anything, right? So if the attacker have the access to the system with the rubber ducky, they can do anything with the system. So those kind of things can happen if you have the company security is not that good. And detectability is a little bit different because the analyzing the training data set will happen less frequently most of the time. And impact also like can generate fault business decisions. As example, this research done by this team in the University of Italy. They have trained a SVM to classify the MNIST dataset. So what they did is they get the input image that has 4 in it, and they change that input image in a way so that the trained model will understand that image as a 0, but the real but the label is there as 4 because the image was number 4. So when the model trains, what is going to happen is the error validation error is going to increase because when the model trains, it's going to identify this number as 0, but the human reading this number, they will see this as 4 and the label is also 4. They can't identify whether there's a problem or not, but the model will see it as a 0. Okay, so they did with this only for a single data point. And they tried that with multiple data points also. So obviously the error rate was increasing. But the problem in this method is now we have multiple errors in the data set. So if a person is looking at the data set, they can identify the errors, these malicious data points. So attackers try to do these kind of attacks with minimal alteration to the data. Another example done by this research team in University of New York, they try to insert a pattern and a single pixel change also to an image. So what they did is they took a random sample of the data set and attached this pattern in the images and change its label to 1. All those images, change the label to 1. And when the model get trained, what happened is the model identify this pattern as 1, not the number 1 as 1. So in the production, when this model is running, the attacker can attach this pattern to any image and upload it to the model, and the model will identify it as one. So this can not only happen, this is not only happening in image data, this can happen in video, audio data as well. Just you have to put a signature and a corresponding label. Another example that happened with Microsoft chatbot called Tay that was released in Twitter. So this is a chatbot that retrained itself with the interaction with humans. So what the people that the users did is they chat with this chatbot in an offensive way. So finally, the model in the Tay AI like read these messages and learn these offensive languages, and he started to tweet these offensive tweets. And the bot was finally removed, but you can find those tweets in a Reddit. There's a subreddit specifically for this chatbot that has all the tweets that was done by this bot. Okay, this is also a very huge area of attack that can happen. So there are some subcategories. First one is label flip attack, where we flip the label of the input data set. So it's going to like mess up your model, and backdoor attack that we discussed earlier, and the adversarial data poison attack, where the input images or input data is changed in a way such that humans can't identify by looking at it, but the model will see that differently. And clean label data attack. So they don't change the label here, only the input data. Like in adversarial data attack, there can be instances where you need to change the label as well. So if you have any questions, I would like you to like stop me and ask. Yeah. As prevention mechanisms, one thing that we can try is, as previously, do data validation. So here it is not input data, but the data set. You have to validate it and sanitize the data. You can have like, if you have a pattern like this, it's going to be represent in static analysis, because it's going to be outlier. So if you have a very good outlier detection, you can easily recognize these kind of attacks if there is any. So you have to secure the data set. You can have proper access control to the data set, and use proper storage mechanisms, and have a physical, in the physical location also you can install CCTV camera and biometric scans. Okay, then regular data auditing also, it's not going to prevent anything, but if there is something wrong in the system, later you can identify those things by auditing your logs. And model regularization, as I mentioned earlier, it will detect most of the outliers, and it will omit outliers with regularization. Yeah. And the model inversion attack, where the attacker tries to reverse engineer the model. Okay, so here what attacker does it? Attacker tries to input some data to the model and read the output. Here, the most of the time, the attacker needs the whole output, not the part of it. And detection is very hard, because unlike in the input manipulation attack, here the attacker doesn't manipulate anything. The input is legit, and output the attacker tries to only read the output. So it's hard to detect these kind of attacks. And in practice, it can alter system data and get confidential information in the system. So an example is a research done by University of Texas, where they get a open source face recognition system. So this as a face recognition system, it will get the face as the input and output a array of numbers. So if the model has 100 users, it will generate a list of 100 elements, and the elements will be corresponding to the likelihood of each user in the system. So let's say the attacker needs to identify some information about the 10th user in the database. So the output that attacker needs from the model is 1 to the 10th element, and all other elements are 0, 1 to the 10th element. So that's the target vector of the attacker, and attacker then try to randomly generate some image or randomly get some images and input that to the face recognition system and read the output of the model. And they change the input images a little and input that again to the system, and they can find the direction that the likelihood values are changing. So they need the likelihood of the target vector where the 10th element is only 1 and others are 0. They try to using the reduction of those, like getting the error between the target vector and the output, they can carefully generate images. So they use a model for that one also, carefully generate images, and they can generate an image that has that likelihood that they target for, at least something close. So with that image they generate, they can identify the facial features of the that person, color of the person, like eye color, eye shape, things like that. Another type of attack is for ad bots. So some people tries to manipulate the ads by clicking them with bots to generate more traffic or to increase the ad revenue. So ad agencies have installed these bot detection algorithms. So these algorithms are also reverse engineered in this way, so that the bot will think the click was done by a real user, not a bot. The algorithm will think the click was done by a real user, not a bot. So these kind of things are available in GitHub also if you search like avoid bot detection algorithm. And for prevention, you can limit the access to the model and its output, because most of the time the whole output is needed for perform such attack. And can do input validation, where check the input range. They can do anomaly scan also, because most of the time the input is changed little by little and given to the model multiple times. So if they can track that pattern, they can detect attack. Also model transparency, we can hide the model. So we don't need to tell the end users whether what the model is or what the model's output is look like. We can hide everything behind our network and only give the relevant users access to the model parameters. And again, the regular monitoring, it's not going to actually prevent much, but we can identify if something is going wrong. And model retraining, because these types of attacks heavily depend on the current model. So if we retrain the model, it's going to prevent. Another one is membership inference attack. So here the attacker tries to identify if given data is in the data set or not. It's also done by having a shadow model. So shadow model is a model that act like the actual model they try to extract, give some data to the model and to get the output, and somehow generate a kind of a data set and train their own model to perform like the actual model. So these kind of attacks mostly happen if the data set has like biased inputs. Yeah. So as prevention mechanism, what we can do is we can always shuffle the data set, and for the output we can obfuscate. That means only the people with the code, people has the code for this one can understand that, and avoid doing overfitting, also going to avoid these kind of attacks, and use high quality data. That means without any data without any correlation. So there is not going to be any bias in the data set, and regular monitoring. Next one, model theft. It's also an attack that try to get the model data, weights and biases and other hyperparameters. So the attacker tries to do that with reverse engineering the model, or can intercept the APIs and try to hack into the system. So you can prevent that with encryption. So if the attacker has the access, they can't use it because the model is encrypted, and you can do access control, model obfuscation on the source code and the dumps, and you can watermark your model so that you can identify some pattern in your model, output of your model, and if the model is used in public later, you can get legal actions. And here also regular monitoring and auditing. Again, it's not going to prevent anything, but we can analyze the behavior later. Yeah, supply chain attack. So there was a very popular supply chain attack few weeks back, I think, like 2 weeks or 3 weeks back, for XYZ utils. So what happens is it's a package that's used in Linux distros, and the attacker had pushed some malicious code to the XYZ that util package, and Linux distros in the alpha versions have used that package in the product in the alpha release, and somehow it was recognized by a tester in who was testing his database. So it was actually done by a regular update, in the code, a regular user who upload the code. He planned that attack for very long time. He was fixing bugs for very long time. He was writing features to the package for a very long time, but suddenly he pushed this malicious code and no one noticed, and it's went to production, but it was identified by a separately unrelated person. Here also, supply chain attack is an attack that can happen in anywhere in the development of AI model. So it from the gathering of data, pre-processing, training, validation, and production as well. So when referring to supply chain attack, it's most of the time we refer to the tools and libraries that you use in such attacks. So as example, the IDs we use, packages that we install in our IDs and install in our code. So that for prevention, what we can do is we can verify package signature, like using hash algorithms or things like that, and we can use a secure package manager like Anaconda. So if you are using Anaconda, it has a inbuilt tool that identify the certificates of the network and see if you are downloading the right package. Otherwise, if someone has access to your network, they can intercept the network and host like fake website. If they host like fake PyPI website, if you go to download a package, it goes through that malicious website instead of the real one. So by analyzing the certificate of the website, we can detect these things. And keeping your package up to date is also going to help. So like a year or so previously, there was an error in log4j package in Java. So it was not a it's not a planned attack, but it was a bug that identified later. So you have to keep your models and keep your packages up to date to mitigate that kind of attacks. And use a virtual environment. So anything anything that happens in the virtual environment, it stays there and not goes to the host system. And as this kind of attack can happen in anywhere in the development stage, you have to educate your employees like developers, data engineers, and other managers about these kind of attacks. This can be done by like getting a ISO certification where they're forced to practice some kind of security guideline throughout the company. So everyone has to follow it. And you can use package verification tools also. I think the time is running, so I will go to these things quickly. First, the other one is transfer learning attack. This happens when the attacker tries to transfer some data in our models. This can done with data sets. So unlike in data poison, they are not going to change the data set, but they will add new data so that our models that train with that data set knows about that information that they added. Another way is they get pre-trained models and change its behavior according to their needs and upload it in somewhere. And if you download it by thinking it's the legitimate data pre-trained model, you are going to have that features that attacker put there. Yeah, here regularly update the data sets and models is going to help. And model skewing will happen when you have a feedback system in your model that regularly updates, and the attacker try to hack into that feedback loop and insert malicious data. So for prevention, you can have proper MLOps systems in your development cycle that can prevent these kind of attacks to the feedback loops and verify authenticity of the data, and anomaly detection can help. And output integrity attack, this mostly happen when you are this mostly happen when you are using a third-party model in your system. Like if you are using API like ChatGPT API, OpenAI API, attacker can intercept that network call and send some wrong output to a model. And this mainly happen if you have a model in your system. So most of the time, to reduce the cost, people tend to train a model and host it in their own network. And their systems are in the cloud. So in the cloud to their internal network, there has to be a link. And this link is not going to be secure most of the time. So it's a place that hackers try to access the model. Again, use a cryptographic method when communicating. So even though the attacker has the access to the data link, they can't read anything. Yeah. Model poisoning is changing the model behavior so that it's most of the time it's unusable. It's not going to like get access to anything for the attacker, but it's going to mess up our systems. Okay, so we'll go to those are the top 10 lists provided by OWASP, and we'll go to this secure development life cycle. It's a standard practice that we do for if we need to securely develop software. First one is threat modeling. You have to analyze your threats in your software and create a table like this exploitability, detectability, impact, and you can have other rows also and create these kind of tables, and you can identify what are the pain points in your system that can targeted by attacker. This list you have to update regularly, because when the software develop, some things can change and new things can add. You have to regularly update it, and you have to think about the data protection, like encrypting the data set and encrypting the databases. If you have a data upload in Google Drive or somewhere, you have to think about the security in there as well. Yeah, and performing regular code reviews so that people can get together, and when performing code reviews, they can identify if there's any risks, and you can run regular vulnerability assessment tools to identify the problems in the code. And like QA testing, you can regularly test your software by attacking it in different ways and try to analyze what happens inside. So with this, by doing these kind of things, you can write a report and you can prioritize what to do next in order to increase the security in your system. By incorporating MLOps practices, you can do this easily. So MLOps person or the team will do these things and suggest that we need this kind of server, this kind of encryption. And with MLOps, it has added an advantage like having CI/CD, regular monitoring, things like that. Another thing is getting modern architectural patterns like a microservice architecture, or at least distributed architecture, where our model is hosted separately in a separate private network, and our core business application is hosted separately in another private network. So when we are communicating between our system and the ML model, we have to use a secure network, secure connection. I have put SSL TLS here to just say any kind of connection that is secure, like it can be HTTPS or RPC call, yeah, a Kafka queue, or maybe things like that. And it's better to have the separate layer in front of ML model to verify who's accessing it. So a kind of authorization layer. So that can, if a request comes to the ML model, that layer can identify from where this request comes, and that request has the proper access to do this action in the ML model. If the model, if that request doesn't have that information, we can directly remove that, reject that request without getting it to the ML model. When we are exposing our system, it's always better to use the API gateway, because most API gateways has authentication and authorization built into them. So if a user with the proper, without the proper authentication authorization, they will the API gateway will reject those requests without forwarding them to the system. And we can do rate limiting, and also data validation we can do in the API gateway level itself without getting the data into our network. We can reject the data there. In addition, there are some security practices in software engineering, like principle of least privilege. That means let's say into your system, we introduce a new server that performs some task. That server can't access anything in the system unless we give the proper access to that system. So it's a least privilege. We give the access when needed, only when needed. And we can have static and dynamic code analysis. There's a popular static code analysis tool called SonarQube. And for dynamic code analysis, there's a open source tool called Fcode that we can use. And dependency scanning, OS also have open source dependency scanning tool. And there's a popular one called Sneak that analyze all your dependencies and tell we give a report with the vulnerabilities in every package. So in the software architecture sense, data encryption at rest and in transit. So data in rest means data that have stored in some place in your system. It can be database or some kind of bucket storage or somewhere. So you have to encrypt those data so that attacker that has access, if attacker get access to that system, they will read that data, but they can't understand because everything is encrypted. And data encryption at transit means when you are transferring data from one system to another system, or when you are requesting data from another system, you have to encrypt those requests. This can be done by secure connections like HTTPS. And other one is zero trust architecture. It's kind of like like least privilege principle, but it's little bit different because although let's say our system was introduced by a new server, like a new server, and that we give that server the access to our ML model, but still the ML model do not trust that server. ML model always tries to, when a request comes, ML model always try to identify where this request originated from, and if this request has the proper access to do these tasks in the system. So it's zero trust. That means no individual servers don't trust anyone in the network, although they are in the same network, they don't trust anyone. Okay, as a summary, we discussed about the top 10 vulnerabilities, and these are the top prevention strategies that we can try. First one is data validation and having adversarial training. That means you can have data that for the human eye that looks like legit, but the model that can identify that differently. This kind of data we can create at the training stage and introduce to the training set of our data set. And continuous model update and implement encryption in the systems and proper access control and regular audits and monitoring. And we discussed about SDL, secure development lifecycle, and how modern architecture approaches like improve the security of individual systems, and some architectural patterns in software engineering, and also ML practices that we can, MLOps practices that we can use. So with these, using these practices, at least try to protect the end users' data in your systems. Again, for this kind of attacks to have a better impact, you have to educate your employees as well in the company. So you have to educate everyone. You can get a certification like ISO 27001 that will force all the employees to practice some kind of security in your organization. Okay, that's it. I will upload this PDF to my LinkedIn if you need, like you can download there. And if you have any questions, you can ask. Yeah.
What is the dependency code called again?
Which one?
You said some tools to check.
Dependency. Yeah, there's a popular tool called Sneak. Yeah, it's a paid one. Yeah.
Is there an open source one?
Open source, the OS organization providing open source one. I can't remember the name exactly. Dependency. Yeah.
Is there any database of vulnerabilities or learning models out there? Where do you get informed about this?
Yeah, so most of the things I got from the OAuth website. The OAuth organization, they provide these lists about the attacks that happen in the world. So,
The one that does every other vulnerability, which covers this.
sorry?
So there are CVEs, like physical database on normal security vulnerabilities, right? These vulnerabilities, do you find one? Where do you publish it?
That publications, I don't know actually about those things, but you can find most of the things in the OS website. OS, like, so they are a separate organization that analyzes. Yeah. They analyze security threats that are reporting in the world, and they create list by ranking them from 1 to 10. Yeah.
Did they found these vulnerabilities in real-world applications?
Real world, I tried to find, but couldn't find any legitimate source providing these kind of attacks. But it's possible to happen because these are not like very hard things to do. Like if you have the proper access, you can do this. So it's finally it's the security vulnerabilities in your system. So if your systems are secure, these things will not happen.
Maybe if I understand that then the second one, the data poison attack, is maybe injecting polluted data
To the data set. Yeah.
Yeah, and I guess there was just one kind of to avoid this kind of prediction or this kind of how to protect this against the attack is validate the data. Or do you validate this data? Is this manual process, automated process?
Yeah. Yeah. So one thing we can do is we can have a statistics model to identify these kind of things, because most of the time, if you do a poison attack, it identify as an outlier. So by identifying outliers, most of the malicious data points we can reduce. So we can't 100% guarantee in any case, but we can try things. The guaranteed, most of the people, the guaranteed ways that they have described is having outlier detections and anomaly detections installed.
This is another machine learning evaluating.
Yeah, yeah. It's so most of these models are not machine learning in the sense of training. Like these are algorithms. So we understand what's happening inside. Most of the machine learning models, we don't know what's happening inside. It's trained and there are weights and biases. We don't know what's happening. But these are algorithms. So as mathematically, those are mathematically proven. Yeah.
question.
Yeah.
Have you faced really some of these attacks in your products?
Not really, actually. Yeah.
Practical experience. I learned a trick about CD. Going to use it.
So if there's no more question, thanks for Ramesh again.
Yeah, thank you very much.